looking back at the history of the department after I came to the department, you can't help but notice the relationship between the evolution of the department, if you will, evolution of the programs in the department, and national trends. Without these national trends, I doubt much of what happened in the department would have happened. For example, in earth science education, earth science teaching, without the experiments of New York State, without the contributions of the National Science Foundation and the development of these programs, educational programs, of which earth science was one, teaching of earth science, I think, would have been relegated to a few states that wanted to teach earth science at the 9th grade level. And certainly there would never have been that national movement. And also there would never have been the innovative kind of education that NSF-sponsored groups brought to it. And it initiated an entirely new way of teaching earth science in the country, and a great response, if you will, to Sputnik. Mm-hmm. If we had lagged, we weren't going to lag before in these areas.
Today, a new moon is in the sky, a 23-inch metal sphere placed in orbit by a Russian rocket. Here, an artist's conception of how the feat was accomplished. A three-stage rocket. Number one, the booster in the class of an intercontinental missile. Its weight estimated at 50 tons. The smaller second stage took over at 5,000 miles an hour and carried on to the highest point reached. 500 miles up, the artificial moon is boosted to a speed counterbalancing the pull of gravity and released. You are hearing the actual signals transmitted by the Earth-circling satellite, one of the great scientific feats of the age.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
My name is Lloyd Schmaltz. I came to Western in 1959. I grew up on the south side of Chicago. One might wonder why a geologist came out of South Chicago, but much of the exposure I had to natural history and geology came after leaving the south side of Chicago. I went to high school there, but I went on to the Marine Corps for 2 years, served on Guam, and which had lots of exposure, a little bit on the volcanic side and large coral reefs, and so and lots of beach exposure. So It acquainted me with the beginning of the soft rock and the hard rock sides of geology. After that, I returned to Chicago, looked around for a college program because I knew I always wanted to go to college. And my brothers instilled that idea in me. And so I ended up going to Augustana College, which just so happened had a fine little geology program with a nice little geology museum. And so I got good exposure there. After my bachelor's degree, I went to the University of Missouri for a master's and a doctorate, and got a little bit of teaching experience because Augustana called me back for 1 year as a sabbatical replacement, which I found very interesting, and it made me interested in pursuing an academic career teaching at the university level. So in 1959, after graduating from the University of Missouri, I came to Western Michigan University, which that's why I'm here. When I was invited to come to Western Michigan University, I found myself as the only geologist amongst 7 geographers, and so the Department of Geography and Geology was the beginning for me. And in that respect, the geology program began in 1959. So what I'd like to say is just try and paint a picture of what the beginning was like. As far as the catalog was concerned, the catalog listed 2 courses in geology as part of the departmental program. One was physical geology, and the other one was historical geology, although historical geology had not been taught for several years. And so my responsibility was to teach the physical geology and introduce new courses as they became popular. Well, popular had to be justified on the basis of prior student enrollment, because all the work had to be justified and new positions had to be provided once the justification was there. So that plan went on, and as we grew during the early 1960s, then we were able to add new faculty members, expand the program, and to do that thing. And so the beginning was a little bit austere. The geology collection consisted of a pile of boulders or cobbles that were collected from the local gravel pits. And there was no hand lens in the department. There was no Brunton compass. There was no microscope. There was no geologic hammer. So all that was beginning at point ground zero. This was the challenge, and I could see that I had to sell geology so we could become part of the other sciences at the university. And the other sciences of biology and physics and chemistry were well recognized because they had been established for a long time, since probably the very beginning of the university. The university itself had only been renamed from a former teachers' college. Prior to that, I would say 59, maybe just by a few years. I don't know the exact date when that took place, but we were under the control of a board of education. We did not have our own board of trustees. Those changes took place a short time after, in the early 60s, where we got our own board of trustees and we could make our own decisions within the university. And so much took place. My role, I felt I had to sell geology, not only to the community, but also to our profession and also to other people within the university. And so the competition was always there for students. We started with the general education program, making sure our courses in geology were accepted as part of the general education. And then we expanded from that point, and it seemed logical because of our teacher education background at this institution, that we focus on an earth science program for teachers in our department. And after 3 or 4 years, we were able to get an earth science major. We had added faculty members. Dr. Richard McGee was the first geologist to come to Western. He was followed by Dr. W. David Kinsey, McGee was mineralogy and hard rock. David Kinsey was a paleontologist and a stratigrapher. So we were growing. And so all this built up. We focused on field trips. We focused on student interest. And we were able to build an enrollment to continue to grow in faculty and in program. And soon after, we moved into the Wood Hall, which occurred sometime probably in 1963 or 1964. We left the old Natural Science Building, which later was named West Hall, which no longer exists. And we then had 2 rooms on the 3rd floor of Wood Hall. And one was an introductory lab for beginning geology. The other room that was assigned to us was a combined mineralogy, petrology lab, along with a paleontology portion of that room. And so this put us on the brink of a major change that took place with the support of George Mallinson, who was Dean of the Graduate College at Western. He was a scientist in teacher education, and he knew the need for a full-blown program in geology and was very supportive. And a major step that took place was he supported us in the application for National Science Foundation institutes, summer institutes, which we were able to obtain during the summer of '65, and that was renewed for another one in the summer of '66. Well, the funding for those programs was approximately $37,000 per year, and that was a major attention gatherer for the administration. Funding for that kind of program was unusual, and George and I, and finally the provost, recognized that an independent geology department was much more able to seek out funds for programs not only in teacher education but also in research. And so that was the crux of why geology was separated from the Department of Geography and Geology. And that took place on July 1st, 1965. And so by that time we had opportunities for new positions. Dr. Skip Davis came with an interest in sedimentology and oceanography, which we needed a lot for our programs. And Dr. Richard Passero, who came to us with a petroleum background and also some teacher education experience. And in this way, we were able to continue to span the program. By 1965, we were on the doorstep of having a geology major, along with our earth science major. And so I think we were on the road to many future opportunities.
I'm Dick Passero. I came to Western in 1966 from Indiana University. I had worked for Texaco for 3 years as an exploration geologist before that, and before that received my master's degree in geology from Miami University in Oxford, Ohio. Well, the department was small when I came. with a focus mainly on undergraduate education. In fact, Western was mainly a teacher-oriented college at the time, university at the time. So the primary function of the department at that time was to complement the teacher education components of the university, and also to promote or teach in an undergraduate program in geology and earth science. But a number of the people in the department had strong research interests which they had carried over from their PhD programs. And so in addition to the undergraduate degrees in geology and earth science, there was somewhat of an emphasis on research, particularly by certain members of the department.
I'm Tom Straw. I started out as a sedimentologist, stratigrapher, working for Big Oil, as it's called these days, and worked going on 6 years for Exxon after having worked for 2 other major companies, not always as a geologist, and decided that this wasn't where I needed to be. And I resigned, went back to school and got a PhD, and I joined the faculty at Western Michigan in September of 1968. Incidentally, you know, the first time I met Lloyd Schmaltz was at the the first meeting of the North Central section of the Geological Society of America's first meeting. It was in Bloomington, Indiana. And Chuck Harrington said, "I'm sure Dr. Schmaltz is over there. Let's go see if we can find him." And he wanted to introduce me to him because he was singing the praises of the department. He was making it seem like if I didn't go there that I was missing the chance of a lifetime.
Being a teacher training institution, most of these sciences offered courses in methods of teaching that science. We had, of course, methods of teaching earth science. And whereas in some other universities that might have been taught in the colleges of education, we taught that within the geology department. And that's one of the things I was responsible for, one of the things I was hired for. Yeah, it was a very important time in earth science education in the country. New York had had developed a program for teaching earth science primarily at the 9th grade level. It was experimental at first, but it proved to be so successful that it was expanded, even to the point where they ended up with a New York State Regents exam in earth science. They were followed by Pennsylvania. Pennsylvania also developed a statewide mandatory earth science class. The earth science was geology, oceanography, meteorology, and astronomy. So in order to teach an earth science program or offer a degree in earth science teaching at Western, we worked with the geography department. Val Eichenlaub taught the course in meteorology. A course in astronomy was taught by Larry Opliger in the physics department. Skip Davis in our department taught the oceanography, and the rest of the courses were in the geology department. There was a lot of controversy nationally whether earth science should be taught in the high schools. Many professionals thought that geology in particular should be reserved for the universities. And what convinced most people that that was not the case was that many schools were offering 2 courses in physical science at the 8th and the 9th grade. And in many cases, the students who did not go into advanced biology, chemistry, and physics were taking the 2nd course in physical science. Well, 2 courses in physical science obviously became a little bit boring in many schools. So the earth science course fit nicely in place as a substitute for the 2nd earth science course in the 9th grade. After Sputnik, there was a wholesale addressing of science education in the country. And the National Science Foundation got involved in it, and NSF then funded and sponsored the development of science courses for primarily at the 9th grade, but also 10th, 11th, and 12th grades. And what they did was they brought together scientists, earth science teachers, science educators into, let's say, maybe 30-day workshops. And the objective was for those people to develop a complete course in that science. There was a group that met for biology, a group that met for astronomy, a group that met for meteorology, a group that met for physics, and a group that met for earth science. The group that met for earth science later became known, produced materials that was later to be referred to as the Earth Science Curriculum Project. And all of these courses that were developed took a different approach, that is a non-traditional approach to science education. The idea was that there would be more student investigation, more open-ended kind of teaching, much more lab-oriented. So all of the materials that were produced, and they actually produced materials for the lab manuals. So teachers who bought into the Earth Science Curriculum Project, for example, bought a complete package of teachers' manual, of lab manual, of teacher's guide, and all the materials that were necessary for the lab part of the course. So the Earth Science Teacher Preparation Project then really propelled the teaching of earth science throughout the country and at a different level.
Mm-hmm.
Western was fortunate enough to become a regional school for teaching the Earth Science Curriculum Project. But in addition to that, NSF funded a follow-up program which was referred to as the Earth Science Teacher Preparation Project. So they followed the development of course materials and inculcating those into the school curriculums with an opportunity to train teachers in a different way. And the Earth Science Teacher Preparation Project, which we were a consortium school in, was designed to make teaching more humane. It was a little bit far out in the sense that they advocated such things as letting the students do their own grading, of addressing teachers and faculty members on a first-name basis. There were a lot of things like that that made it very difficult for particularly the geology departments to adopt.
Sure.
But we did have a conference at Western, and Western did give it a go. It was a little bit difficult for the department to accept it, but we tried. And the main thing was that Western then was in the mainstream of earth science education. Between the Earth Science Curriculum Project and the ESTP, the Earth Science Teacher Preparation Project, we had become known as one of the better schools for training earth science teachers and doing it in a very contemporary way.
Soon after the department became a department, we realized that the facilities at Woodhull were not adequate for a full-grown program, because we thought that before long we would also seek courses and faculty to support a graduate program both in earth science education and in geology. And so we were on that verge, and we started to think about facilities. The university was amenable to this, and they suggested that we plan for new facilities across from Woodhull on campus, and which ended up being Everett Tower and Rood Hall. And so in this regard, much planning had to take place. Well, the original idea was to make a big box, at least the academic part. The tower was devoted for faculty offices. And so we wanted to make as large a facility as we could, because we had plans for future programs we had for a growing number of students and so forth. That didn't work out very well because we did start with a very sizable academic building, but the physics department intended to put a linear accelerator underground as part of the Rood Hall complex. And the expense to do that increased twice. And each time the expense to do that, we had to shave the size of the academic building. And so if anyone walks down Wood Hall today, they know that the faculty offices are a little small. Slices were taken out of the original size of the faculty office. The same is true for the departmental office. And the same was true for the academic portion of the facility that we wanted. But we also wanted to focus on where we would be in that building. The faculty of the other two departments seemed to want to isolate themselves in the tower. And so that's what happened. I wanted exposure so students would see us and enroll in our classes, along with some space for a modest little museum, because the teaching museum was part of my background, and I saw its value, and I thought that it would be an attraction to uncommitted students that might like geology or earth science as careers. And so that's the way it ended. We strived to get the first floor, which we ended up being able to do, along with the lecture hall. And so the facilities that you see today, with the expanded ones for research in other buildings, represents the Department of Geosciences as we know it. On October 25th, 1970, we were able to move into Rood Hall, and this little booklet shows the dedication program. And sitting in the audience, I had the opportunity to get the perspective of what geology was thought of for the time. And the presenters at the program went through a very nice little description of the large mathematics department, and with very flowering references, and the same was true for the physics department. And then they finally got around to saying the other department, and the audience chuckled, and I had to bite my tongue a little bit, but nevertheless, I would like to compare what the reputation of geology and geoscience now today is with the respect that we have on campus. And many of you may have noted that in a recent issue of the U.S. News and World Report, geological evaluations were taking place at many graduate programs across the country. And Western Michigan University received a very high ranking for the geosciences graduate program, and none of the other sciences at Western were rated. So I wished I could see the faces on some of the presenters at this dedication now.
My name is William B. Harrison III, and I came to Western in 1973. When I came to the department, there were 5 permanent faculty members, and that year they hired 3 more, and we got to a staff size of 8. They hired a geophysicist, igneous and metamorphic petrologist, Dr. Ron Chase, and they hired me as a paleontologist. I was to teach invertebrate paleontology, historical geology, and oceanography. My background, I went to school at the University of Cincinnati and at the University of South Florida, and learned a little bit about marine geology and marine biology when I was there, so they had me teaching oceanography classes. But in addition to that, I taught most of the sedimentary geology classes over those years through the mid and late 1970s. I taught invertebrate and vertebrate paleontology and historical geology. And then I taught as, we had a sedimentologist, Dr. David Kinsey, but he passed away, and I took over teaching all of his classes as well, and that included sedimentation and stratigraphy and carbonate sedimentology and sedimentary petrology. After I'd been here just a couple of years, I started taking on graduate students to supervise, and at that time the department had just a master's program. As the department started out, it started out with earth science and then had geology. And the first students I had, because I'd done work in the area around Cincinnati, I had taken several of the new graduate students down there on field trips, and they were doing their thesis research projects on Ordovician and Silurian age rocks in the Cincinnati area. And then after a few more years, into the late 70s and early 80s, a few of the students started showing interest in Michigan geology, and we began to look at some of the outcrop areas up in northern Michigan, along the lake shore where some of the quarries were. And I think over the last 35 years or so, I've probably supervised about 50 master's students and a couple of PhD students as well. And I served on a number of additional student committees. And I'm still serving on graduate student committees, although since I retired from teaching, I can't be the major supervisor anymore.
Hi, I'm Ron Chase. I was a faculty member in this department for 39 years, starting in 1973 when I was hired in as an associate professor of geology, and ending in 2012 when I finally decided to retire. My teaching assignments in the department were largely originally in the areas of petrology and structural geology. I was relieved of the structural geology duties and glad to pass them off to a very wonderful structural geologist named Chris Schmidt, and continued with the petrology duties for the remainder of my career, and actually kind of got also eventually into the earth science teaching field toward the latter part of my career.
When OPEC decided that it was going to have an embargo on oil to the United States in particular, and the oil industry started laying off geologists at the time, we were able to at least think in terms of what the future would be. And recognizing that petroleum geology, which was hiring most of the geologists that were graduating, and in some cases, a company like BP would hire 80 petroleum geologists in 1 year, and they'd hire 4 the next year. So even though it wasn't a matter of the end of the petroleum industry as far as hiring it was concerned, it was certainly recognized that it was going to be pretty cyclical from then on. And so we took a look at the future of the geology department, and some geology departments were having a hard time. 1 or 2 even closed down. What we decided to do was to develop a master plan for the department. The master plan, the emphasis in the master plan was on the environment. It was fortunate because at the time, an emphasis on the environment simply complemented the geology program. This was not to replace the geology program. This was to address another societal need. And at that time, the federal government, as it did in education, there was a coincidence with what the federal government was doing in the environment and what we were thinking of in our program. For example, the United States Geological Survey, which at first didn't even want to use the term environmental geology because the idea was that all geology is environmental. But because of the the emphasis that certain geologists in USGS placed on it, USGS began to produce materials that were different from what they had produced before. I worked for USGS for a summer and spent a sabbatical with them. And the traditional geology that USGS did was basic mapping. You map the distribution of rocks and their spatial relationships. But what was missing was the translation of those basic maps into material that could be easily understood by other professions and the general public. For example, if you gave a basic geologic map to an engineer, all it would tell him would be the distribution of rocks. It wouldn't tell him the properties of the rocks. It wouldn't tell him whether rocks in one area were more or less suitable for tunnel construction or whatever. So USGS began to produce maps. A friend of mine produced a map in the San Francisco Bay Area, a number of them as a matter of fact, on slope stability. So what he was pointing out was then where you really shouldn't build, where the slopes were unstable enough. The building community didn't like that very much, but it was necessary. They began producing seismic risk maps, which showed zones adjacent to faults, not only mapping the faults, but showing the zones of risk adjacent to faults, which again the building community didn't like very much, but it was done. And they produced a series of maps which were different than anything they had done before, but could be then used directly by planners, and planners are one of the most important users of these maps, by other professional communities. So what happened was then a trend was established in the United States Geological Survey and across the country in producing geologic materials for use by society. No one abandoned the traditional geology. Yeah. This was, again, like the education, this was a supplement or a complement to what had been done previously. What we had was a national framework then for what environmental geology was and what it was to become. Even the definition of environmental geology was something that was controversial. But with this national program or trend, then it was easy for the geology department to teach, for example, a course in environmental geology. In fact, NSF offered a short course in environmental geology, and I was privileged enough to attend that. And it started in Salt Lake City, went all the way down to Los Angeles and up to San Francisco. And what we did was we looked at geologic problems along the way, and we looked at what was being done. We looked at the nature of the problem. So I was able to come back to the university with a host of slides, for example, of massive landslides in Santa Barbara, California, of waste disposal problems. And that then formed a basis for a course which I developed, which was environmental geology. So the importance of it wasn't an academic course as such. It was what a lot of our work was applied. And you could call this applied environmental geology, if you will. So I was able to bring all of that information back into the classroom, and I think it gave some solidity to the environmental program.
Yes, I remember this very well. I was really surprised that once it got started, it just unfolded. Everybody that was supposed to be in a place was in a place. The people to introduce the programs were right where they belonged, and there wasn't much I could have done if they weren't. But I was really, and the department was particularly well situated and suited for that program, because we had those two large lecture rooms that were, well, actually three, just very close together, and it was a really good place to have that program. It says here that I was the program chairman, but I was also in charge of the guidebooks and field trips. And we had 5 guidebooks, and this guidebook was printed and produced at Western, at the printing department. And when Bob Shaver from Indiana University saw those 5 publications, he looked at them and he said, "You really did this right? They did this right here at this university?" I said, "Yeah, we didn't take it out. This was done here." And he was very impressed.
As we grew, the research interests in the faculty and the programs became very, very important. And I just would like to point out some of the accomplishments of the faculty. This is one very notable one. You can see it's been well used, and it's the Kalamazoo County Geology and the Environment. And this came about the time the department was making a major change in its philosophy. Rather than to try all aspects of our profession, we decided to focus on groundwater education in geology and also in environmental geology. And this, I think, could be construed as the first step in this direction. And so this received a lot of attention, and from that point on, I think the reputation in environmental geology really grew for the department.
We began with a very small start, if you will. But we knew that we had to produce material. If we were going to do this, we had to produce materials. We had to prove that we were interested enough to provide materials locally that society could use. And one of the first things we did was to produce this this booklet, which was Kalamazoo County Geology and the Environment. And the nice thing about this book was that everyone in the department contributed a section, and even people in other departments. So we took everything from groundwater, surface water, agriculture, weather, and had enough people interested enough to write sections of the report. And then we in the department put it together into the booklet that you see here, and it was very popular.
The origin of this also has a bit of a story behind it, because the way we got into an environmental emphasis in the department was that we had convinced the administration to give us an additional position for geophysicists, and we had hired Charles Scharnberger to do that.
Yeah.
Well, along came, as it inevitably does, a reduction in force, and we lost Charlie's position, and so he accepted a job at Millersburg State University in eastern Pennsylvania. Well, Dick Passero had just come back from spending a sabbatical year with USGS, Palo Alto, California, and he spent time with them and also taking coursework at Stanford. So he came back all primed. He went out there to work with a friend of his, one Earl Brab, a USGS person, and he came back really fired up to do environmental geology. And so he had developed coursework and was teaching that. And he said perhaps a way we could convince the administration to fund us, because the environmental thing was very hot at that time, would be to convince them to fund us to have an environmental emphasis in the department. Well, Dick, Lloyd, and I worked to put together a proposal that we then got together with the associate dean and the dean, and I presented because I was chair at the time and that was my responsibility, and it went very well. The dean agreed that they would give us the position back, and help us otherwise. And part of the deal that we presented was that the department would prepare a book about the environmental geology of Kalamazoo County, and that this book is that book, Kalamazoo County Geology and the Environment. And it was done in the Jubilee year of, I guess that was 1978. When it came out, Art Slaughter, who was then state geologist, called me and he says, "Tom, all I've got to say is you can do all the rest of the counties anytime you're ready." So we were very pleased with the reception of it, but it also made a good, verifiable thing when we said we could do something and would do something. When we talked to the EPA, we took this along.
The Environmental Protection Agency was seeking universities that would be willing to take on a major research project investigating the groundwater of the state of Michigan. And I know that they approached the University of Michigan first. They also approached Michigan State. I'm not sure whether Wayne State had been approached or not, but then we were invited to consider it. And after meetings and deliberations with the faculty, we took on that endeavor. And it was a major endeavor.
When I returned from Butte, Montana, from being on sabbatical at the beginning of the 1979 school year, Dick Passero and Lloyd Schmaltz were preparing a presentation for the US EPA. They were going to fund a contract for some $350,000 to develop the geology of Michigan for groundwater injection. And they invited me to go with them at the presentation, and we did that and were awarded that contract. And I think it changed all of our lives, because we went from having teaching responsibilities, research responsibilities, to having grant responsibilities, and that's pretty definite, because there is a deadline that you have to produce the producibles on. We had to produce this publication, and the US EPA extended the contract a couple of times, and I believe that the total amount of the funding was over $700,000.
Wow.
And we used most of that money to fund something over 20 students to do the work and help us with the work. And I always thought of it as getting double duty for the money, because we were having students go to school on the money we were bringing in, and they were learning it all at the same time. It was a very good time for us. It was a very exciting time.
Well, our emphasis in the environmental area and the experience I had with the United States Geological Survey set us apart from a lot of the more traditionally oriented geology departments in the country. As a result of that, when EPA, as part of this environmental emphasis that was developing nationally, developed the Underground Injection Control Project. Each state then was going to receive a grant. Somebody in the state was going to receive a grant to produce the materials necessary to decide whether underground injection of wastewater was feasible, what the limitations were, what the hazards might be in the existing wells. Michigan had, at the time, 18 deep disposal wells. Upjohn, locally, had 2 of them.
Yeah.
And this was a matter of injecting wastewater into underground formations, it's referred to deep, but in some cases in Michigan, these disposal wells were maybe only 500 feet deep. Obviously, then it could threaten groundwater supplies, groundwater resources. So EPA came to Lansing, and a number of schools were interested in bidding on this project. Fortunately for us, because of our emphasis in the environment, we knew something about environmental geology. We had started to do environmental geology. And I think it so impressed EPA that not only did we go and ask for money, but we were able to give them an overview of what we would do and how we would do it. And we won the contract, which was $634,000. And the beauty of it was that it enabled us to hire about 30 graduate assistants to work on the project.
Yeah.
Now, what we had to do was to evaluate all of the geological materials available in the state and to somehow synthesize them for people who might want to decide on whether they would put in a deep disposal well or whether they would approve of a deep disposal well. We took it a step further, and I guess we turned out to be the envy of many other states, because what we did was we produced many maps, not only the ones that were available, like basic geology maps in the state, but we produced complementary maps of, let's say, groundwater contamination sites and that sort of thing. And we ended up with what was referred to as the Hydrogeologic Atlas of Michigan. And this was a very large publication, and it sold 100 copies. Because what it ended up being was not only resources to determine whether you could put in deep disposal wells, but it was a compilation of all of the geologic and hydrogeologic maps available in the state. So many people, engineering firms and so on, were interested in having a copy of the publication, even though they might not be doing anything with deep disposal wells.
Yeah.